Hi, welcome to Pursuitery. This is an Arduino Geek Out, and today we're going to learn all about Spark.io, how to control devices through the internet and Wi-Fi. And our guest hosts are going to be Teak and Paul, and I'm going to ask people to introduce yourselves. So, Anne, I know you don't have a microphone, but if you want to type your intro into the chat, please feel free. Caleb, would you like to introduce yourself? Caleb, you need to unmute.
Yeah. Oh, sorry. Yep. I'm currently in Bath, UK. I'm a PhD student.
Welcome. Ignacio?
Hello. I'm Ignacio. I'm from Mexico, and I just grabbed a Spark.io to see the fun of that. So I'm here.
Paul.
Hi, my name is Paul Careni. I'm from Ottawa, Canada. I'm actually a Spark Elite, so I don't work with these guys. I just I got onto the forum, bought their product, loved it so much, and started helping others while I was doing my stuff. And they made me this thing called an Elite. I still don't know what it is, but you know, it's fun, and I just like to share my excitement for this product and the stuff we can do with it. And hopefully I'll be able to help you understand what I know.
Great. Evan?
My name's Evan. I'm the web wrangler for Pursuitery.com, and if you get a overly enthusiastic tweet or read an overly enthusiastic post, I was most likely the person that wrote it.
Never too much enthusiasm.
Oh, true, I try.
Hi there, I'm Teak O'Reilly. I'm actually the closest to Spark headquarters. I'm here in Minneapolis, but I'm in my little apartment in downtown. I had the good fortune of meeting Paul this spring at Maker Faire in San Francisco, and was really impressed by his educational chops and just kind of natural passion for what we do. But yeah, I'm just here to moderate and to hopefully help field questions from the chat room, and also help Paul get up some visual materials up on the on my screen share. But if you have any questions that you do not get answered in this session, feel free to write me at teeke, T-E-K-E, at spark.io, and I'll put that in the chat. But I'm really glad that everybody showed up, and Paul, I'm really looking forward to watching one of your tours, man.
Great.
Uh-oh.
I'm Howard Reingold, and I'm the Arduino host for Pursuitery. If you follow me on Pursuitery, then you will get notified whenever we set up an Arduino Geek Out. So, take it away, Teak and Paul.
All right. Okay, guys, so, I mean, all of you are here for, obviously, because you're curious about this product. I want to thank you, Howard, for inviting us and allowing us to use your great, you know, geek out environment. I watched a lot of the stuff. It's a lot of fun, and I really like your take on it. Evan, thank you for being the guy. Could you bring up the page, the features page that I sent you the shortcut to, please? And if everybody wants to kind of click on that, that'd be great. I'm just going to talk and point to some screens, and then I'll show you some stuff. The cool thing about Spark is it started off as a Kickstarter campaign that failed. So you know, if something fails and then eventually comes back and succeeds, it's because there are people behind it that are really committed. So you know, the cool thing about and don't be afraid to click on Teak's screen, little window there, to see what that page is. So Spark started out as a failed Kickstarter campaign, and then had a very successful secondary campaign. And what it was all about, what the thing that interested so many people is it was a tiny kind of product that had Wi-Fi and more. It was the ability to build an Internet of Things with a simple product that was affordable and not complicated to use. So one of the things that you will see when you get to the Spark.io page is this whole features thing, and I'm going to speak to it because this is actually honed from a lot of the feedback that several members and elites gave, and a lot of introspection as to what this product is and can do. So, you know what? I'll be honest with you. Arduino, the simple Arduino stuff is kind of aimed at beginners. We shoot at intermediate to advanced folks, including corporations and enterprises that want to use a product that's ready to go. And what I mean by beginners versus intermediate is we expect when you use this product, you should know the basics of programming for Arduino, or at least in C++. You should know the basics of what a microcontroller is and how to interface with stuff. And I'm assuming that everyone here has had some exposure to Arduino and things like that. Has anybody not got any exposure to that? And you can text me or say it on your microphone. Okay, so everybody's got exposure to some extent, and I notice you're starting this library thing, which I think is great. So what is the Spark? It's that little thing you see in Teek's picture there, is that little kind of Arduino Pro Mini looking thing with a shiny top on it. And what's really cool about that is that it's not big. It can be built into projects really easily, and it's very straightforward to build. What's cool is that it doesn't use a small processor. It uses an ARM Cortex M3. What the ARM means some serious kind of processing power, going at 72 megahertz. But at the same time, it's an M3, and the M stands for microcontroller class. That means it's got a lot of input-outputs that you can control, a lot of integrated peripherals like timers and interfaces for sensors and so on that are common to the M class of ARM processors. So the foundation for Spark is really a fast kind of core, and then on top of that you add the Texas Instruments CC3000 wireless module, which we see on top as that shiny little kind of a square or rectangle on top of the Spark, and that's the Wi-Fi module that is built in. So really, you start. If I was to do the same thing with an Arduino, I'd have an Arduino plus a Wi-Fi shield that I'd add on top. So the cost for all that is $39. So it's really affordable for anyone that wants to build kind of a project with Wi-Fi on it. Now, for developing, what's really cool with the Spark is there's there's 3 different ways you can actually develop for this product. For beginners, there's the Web IDE, which means that you use the web to create your code, and then you can flash it or send it to your core, your Spark core. And this is the cool part about the Spark, is you can actually flash it over the air, over Wi-Fi. You don't actually have to be connected to it. So that's a big bonus, especially if you're not near your core. Or you can do it over USB. So the Web IDE allows you to kind of get up to speed really quickly, put up some code. You have access to some libraries, and we're growing them. And or you can bring in your own libraries and do stuff there. The second way to kind of do work with the Spark core is what we call the CLI, or the command line interface. Now, some of you will use Linux, some of you will use Windows, and some of you will use Macs. All of these things that I'm mentioning so far are fully compatible with all those operating systems. So, you know, we have a great community where we find glitches, but what's really cool is that we're not stuck to one environment. And if you want to use the command line interface, what's really cool with that is you can actually use Spark's compilers on the cloud, but everything happens on your PC. So you're using their servers, but all the commands are being issued from a command line on your own computer. So that's kind of cool. And you can do everything with the Spark CLI, including flashing via USB if you want, or sending over the air by Wi-Fi. It's a great way to interact with the core. There's another method, because the Spark core is completely open source. It means you have access to all of the libraries. Everything is open, even the bootloader. There's nothing is hidden in any way, shape, or form, except for anything that might be hidden by Texas Instruments in their part of the world. But we don't really have control over that. So what's really cool is you can download the entire GitHub repo for the entire project, and download also your tool chain, which is the GCC tool chain, to build all of that locally, and you can modify the entire code any which way you want. So for some people, they really like the core, but they might want to do their own thing with the software. We've had some members do NutX and other operating systems on the core, and others modify functions. And we have some members who've added a lot of functions, which is really exciting. So what's this thing with the Spark core that makes it different than an Arduino and a Shield? Well, there's something that is really important. One of the things that comes built into the core when you get it is some firmware that comes in your core that is designed specifically to connect to their cloud operating system. And we hear a lot about clouds. Well, what does that mean, their cloud OS? Well, their OS allows you to manage your cores and also access your cores from anywhere on the internet through an API. So it means now that I can actually access the core by having the core use certain cloud functions that are built in. I don't have to write that. I don't have to get special libraries. They're all built in. So that cloud connection is all ready to go. So for example, if we look on the screen that Teek brought up, you'll see there's a spark.function. That's a function that's built in and essentially allows me through the API in the cloud to send a command to a function on my Spark core. And then I pass an argument, and it might be a command. It might be a whole set of commands. And so that function will be called, and that's a function that I can define, will be called through the API. So I can talk to the core that way. Another way is to expose a variable through the spark.variable. You'll notice that as well. So I can have a variable in my code that gets exposed to the cloud that I can access from a web page or any web-based application. It could be Python, or it could be Node.js. It could be anything I want. As long as I can form a request and send it, I can access those variables through the API. There's also a Spark publish and a Spark subscribe. So Teek, if you could go a little lower, I'll show you the cool thing. Again, you can actually publish stuff to the cloud, and then you could have another core subscribe to that, or you could have your own application subscribe to that published event. So you can see that the Spark core simplifies for the user the interface with the cloud part, and their cloud OS makes talking to my core really, really straightforward. So the Web IDE leverages the Web OS to send the firmware I want to update via the Wi-Fi OTA, so I can program stuff over the air or via USB. So they really leverage that cloud operating system. And more functions are being added to that cloud operating system to leverage, to use within the Spark core. So what does that mean? It means I have to code less. I can leverage a lot of the functionality from the core and not have to make a heavy program to do simple things over the web. That's really cool. So again, the hardware, the firmware, everything is open source. So much so that just recently they released a local cloud version which allows you to run your own miniature cloud with a few less functions unless you have a server farm that you can build in your basement. But you can run it on a Raspberry Pi. And you can do stuff like manage your cores, and it has the same API, and you can talk to your cores. And so, you know, they're so open that they share that stuff with you, and as it evolves, all of that is shared. So that's a really, really powerful kind of environment to develop in. For corporations, obviously, they have all of that at their ready, and they can take those you know, FCC approved designs, and they can take those things and then leverage that Cloud OS in ways, you know, in volumes that possibly you and me will never get to, but they can certainly leverage those things, and that's what makes it exciting. So does anybody have any kind of questions right now about that, about what I've discussed so far? Don't be afraid to put on your microphones.
Well, okay, I've got a question.
Yeah.
So I've got, let's say, just a kind of simple setup. You've got like an RGB LED, and you've written a script, and when you turn power on, it does something.
Yeah.
How would I do that with a Spark core?
Well, that, you know, Howard, that's a great question. And let's go back a little bit to, and I'm just going to think here. So a couple of things I got to discuss. First is the core communicates with the cloud via a secure environment using what's called COAP. So you don't have to worry about open stuff. They use keys and tokens to be able to provide security. So it's a really secure environment. The language that we use is, I'd like to say that the core is exactly Arduino compatible, but you can't use the Arduino IDE to develop your code. But anybody who's familiar with C++ and what's called wiring, you know, the fundamental commands that are known to Arduino, will be able to program at the core. When you start using very specific hardware stuff, it's a bit different than the Arduino. But we have a great community that can explain the differences if and when you hit those. So by writing a simple C++ program, you can, Howard, you could control that LED like you would in Arduino, but then you could have a Spark function that allows you to change, say, the colors by calling that function from, say, a web page, and passing in an argument that is the color that you desire. And then your Spark code would simply take those colors, strip them out of the command of the argument, and then pass those to the RGB LED as required, using most likely pulse width modulation like you would in an Arduino for controlling the brightness of each one of those LEDs. Does that answer your question?
Yeah. Well, it raises another question. If you are interested, I would love to have a geek out in which we actually do that.
Well, I'm going to show you before. In today's session, we're not going to do a cool RGB, but we're going to do a simple LED. And what's cool is when you get your box with your Spark core in it, you're going to get out of the box an application that we call Tinker, and it allows you to control the pins on the actual core through your phone or through your iPad or whatever device you have that you want to do. We actually have an app that allows you to do that, and I'll show you guys that because it's exciting. So, Teak, if I'm missing anything, please let me know. The cool thing now is that we've got you know, an Arduino-ish, so anybody who's done Arduino will be familiar with this thing. We've got several development environments that would suit your requirements based on what you want to do. We have the ability to connect out of the box with this cloud environment, this Cloud OS that allows us to talk to our course from anywhere in the world. We have internet access. Or, and I need to make this clear, you don't have to have that. You don't even have to have Wi-Fi. If you want to disable those, it'll act like just a good high-speed processor. But then that would be kind of wasting the module. So that stuff is all there out of the box. Okay. Can I just ask you to go to the firmware tab, T, so that we can just briefly talk about some of the commands and stuff. Okay, so there's a lot of online help that is available through Spark. And I just want you to scroll down just a little bit, and I'm just going to very, very quickly, but you'll notice that we talked about the Spark variable and Spark function, but you'll also see that you can connect and disconnect from that cloud as you wish. We even have Spark time, because now we're on the internet and we have a bunch of servers in the cloud. Well, the Spark has a built-in real-time clock. So, and it'll synchronize itself to the cloud so that you don't have to add that as an extra module. Is that cool or what? So a lot of projects can take advantage of that. And if we go down a little bit, we have some sleep modes for reducing power. And just in brief, on the left-hand side, if you could, Teak, so that they can see more of the functions. Fundamentally, the Spark has 7 or 8 digital I/O lines. It has 8 analog I/O lines. Of course, there's a mix of pulse width modulation capability in those lines. And we have SPI for talking to SPI-enabled devices. We have I2C. We have at least 2 serial ports, one being the USB that you can use for debugging, and the other one being on the pins of the core that you can use for interfacing with devices. And we're now working on a 3rd serial port for just because we can. And so and I got to tell you, the community has huge input into the kind of capabilities that get added over time, and that alone is really cool. So the other things that are built in that you would normally have to add on an Arduino is UDP and TCP client and HTTP server. So all of these things are built in to the libraries that you can use. So again, out of the box, you're ready to go. So and you'll see that we have some servo libraries. There's an RGB LED built on that we use for giving status. If it's connected to the internet, connected to Wi-Fi. But if you want your code to take that over, you can. So, I don't want to go into too much detail here. What I really want to do is kind of move on to showing you a core and showing you how we bring it online. Does anybody have any questions?
Go.
Cool. Okay. So there's your Spark core, brand new shiny box you just received in the mail. Well, okay, or whatever. And when you open your box, you'll notice this nice kind of padding. And what comes with the Spark is a proto board, so you don't have to get one for yourself. There's the Spark core. And under here is a USB cable that you can use. So right out of the box, you can start using your core. So again, I'm just going to point out here, there's a USB connector that you can power off of. You can also power off directly from pins using 5 volts or a maximum of 6 volts, or you can power via 3.3 volts. And there's enough juice on here from the 5 volts that you can supply from the 3.3 volts some of your sensors and so on. And also, there's an output from the voltage of the USB that you can power stuff with as well. Okay, so I'm going to disappear and I'm going to move my camera so you guys can see me power this thing. And this is fresh out of the box. So let me just move my camera. I apologize for not having a second working camera. And I'm just going to power this on. Okay, so, and you know what, guys? I'm just going to do something here that allows me to zoom in here. Okay. Oops. My apology for stalling. All right. Can everybody see that? Yeah. Okay.
Yeah.
Oops. Okay. So you'll notice that you may not, the color, but you'll notice there's a blue LED flashing. And that's because the Spark core, it has a Wi-Fi module that doesn't know how to hook up to Wi-Fi yet. So now all I need to do is start an application, and I've got an Android phone here, and there is, whoops, that's good. And there is a Spark application on my phone. There, is this upside down? No. Okay, so there's the Spark application, and you'll notice now, and I'm just going to zoom out here. You'll notice that my phone looks like a big Spark with all its pins. Now, part of that application allows me to add a new core. So I've got a brand new core here that I need to add and take ownership of. So I'm going to do that by simply opening my application, and now it's already figured out what the nearest router is, and the Spark is most likely connected to it, trying to connect to it because it's right next to my monitor here. And I'm going to type in the router's password off screen. Don't ask me why. So
Hello?
yeah, are you guys there?
Yeah.
Okay, hopefully I typed it in correctly. Okay, so you'll notice now that the LED, the blue blink, has stopped blinking. And I'm going to do this a little bit here. And now it started flashing green, which means okay, so it flashed green, and now it flashed blue, and then it's now pulsing blue. So the green part said, I connected to my router. The blue part said, I'm actually connected to the Spark Cloud. And it disconnected because I've got the phone right next to it. All right, so now I'm actually connected to the Spark Cloud, and bear with me because I just need to wait for my somewhat slow phone to finish doing what it's doing. Okay, bear with me here. Okay, so it's that easy to take control of the core simply by using a phone application. You can use your PC, you can use USB, you can use a tablet. All of those things are available. And I'm just going to wait now. I put in the wrong password. Sorry, guys. Okay, so I'm just going to reset this here, and again, this is my phone doing funny things, and of course, this is something not work for you. So I'm retaking ownership. There's the green. There's the blue. Okay. And I'm just waiting for my app to complete. Okay, there we go. And now you'll notice that it's asking me to name my core, and the core is the name that it's suggesting is Hamster Wombat. So I'm going to hit OK on that. And now I will have access to the core named Hamster Wombat. Okay, so now Hamster Wombat should be available to me, and you'll notice here that I'm going to turn this upside down. On my phone, I have Hamster Wombat on this application, and much like Arduino on pin 13, you have an LED on the Uno. On pin D7 of the Spark, you have an LED. So Howard, I'm going to say D7 is going to be a digital write pin, and then I'm going to tell it to actually write a different value, a high, and you'll notice now, and I apologize, that the LED is now off. Can you guys see that?
Yeah.
Okay. So I'm doing this over the internet. Okay.
Yeah.
Okay. So I can now control any of the pins on this Spark with an application or a web page anywhere on the internet. And you know, the cool thing about the application is also has, I can do an analog read or an analog write on those pins. So that's built into the device right out of the box. And when you send your own firmware on there, of course, it'll erase that application. But that application is open source, so it's available anytime you want to put it back on. And it's really simple. So you guys see that? All right.
Yeah.
So, you know, and that RGB LED that I was pointing to earlier, this one here, that is kind of a status indicator, I could take it over and change all the colors if I wanted to. I like it as a status indicator because it's telling me if I'm screwing up or not. All right? So that's how easy, out of the box, I can already do stuff with the Spark Core. And what's really cool is out of the... so imagine taking that core and adding one of their shields, which is a relay shield, and I would put the core in right here, and then I could control, using my application here, I could control those relays. Of course, I could also write software or firmware or program that goes on here that controls the relays with sensors and so on. But you know, again, this shield, for example, simplifies relay controls really easily. So that's really cool. And there are more shields on the way, and certainly the community is really busy. So that's how simple it is to take ownership and to take care of a shield and to actually control a shield right off the bat. Now, let's take that to another level where I can read sensors, and I can react to those sensors, and then control all sorts of things, either by reporting back or by sending through publishing. A lot of people, what they do is they publish sensor data to say a Google spreadsheet or to a website for collecting data. They also we have a cool, one of our members designed a cool shield just recently for adding an SD card or adding FRAM, which is really high-speed, non-volatile RAM. So that's really cool. Our website, the website has all of the instructions for getting started, connecting. There's another shield that was brought up, which is an Arduino shield, so you can use the standard Arduino shields with some restrictions, but you can do that. We've got a cool power shield coming up that will allow you to connect a solar cell and other things. So the thing about the Spark is literally out of the box you can start controlling things via remote. And you see here, could you scroll back up, Teak, and you'll see the relay shield here, and some of the sample code a little further down is that code uses a Spark function to pass a command that says turn on a specific relay, and so that relay is called via Spark function, and then you can control your relays remotely or through an application that you've written that talks to the web. Node.js and Python seem to be very popular. You could do it on a Pi, or I have Node.js running on my little Atom 270 laptop here. There's not, because the Spark does so much and the cloud does so much, it just simplifies the integration a lot. Okay, so I've said a lot. Does anybody have any questions so far? I encourage questions.
I think I have one.
Yes.
I was reading the documentation, and I saw these input pull-ups and input pull-downs, but I saw that it's something related to the ground pin. What's the meaning of this extra input pull-ups and pull-downs?
Pull-up and pull-down? Well, much like some Arduinos, there's a relatively weak pull-up and pull-down resistor that you can activate using the pin mode command, much like in Arduino. And the pull-up will go to the 3.3 volt rail because the Spark, much like the Arduino Due and newer processors, operates at 3.3 volts. And the pull-down will pull it down to ground. So that means that your signal will, by default, the pin will either seem to be high or seem to be low by default. A lot of people don't rely on those internal pull-ups because they are relatively weak and they may want something stronger. Does that answer your question?
Yes.
Perfect.
Good. The other one is I saw that also these interrupt functions. Well, what can I do with those functions?
Which functions?
Interrupts.
Interrupts?
Yep.
Just like
Yes.
Arduino, any of the pins on the Spark can be designated as creating an interrupt. So what you do is you attach an interrupt to a pin, and you specify the function to call when the condition of the interrupt is met. For example, rising edge, falling edge, or any edge. You have any questions? And bear with me because I know you have to type. Recently, one of our libraries, the Library of Ottawa, opened a makerspace, and the cool thing with the Wi-Fi stuff, along with all the other types of wireless, is that it fits well within this kind of controlled world, the Internet of Things. And besides the obvious accessing 3D things and laser cutters and so on, the idea of having these simple Spark devices that can allow you access to the entire kind of Internet of Things world is really cool. I have actually one of these devices acting as I bought a SmartThing hub, and I'm actually developing SmartThing devices with Spark cores, which means that Spark cores can be used in so many things. It's really amazing. Anything that can talk over the web, the Spark core can most likely integrate with it. Any other questions? Anyone? I know people have questions because this thing opens up a whole bunch of possibilities. I certainly invite you to go to the Spark community, the forum, because you'll discover in there a very vibrant community of people answering stuff. And if you have questions, go there. We even answer questions from people who thought we were a different product. So we're very open-minded and helpful. One of the things that if you want to culminate in is a project I did, and I'm going to demo this and hopefully stimulate more questions. The usual. Okay, well that's a really good question. Okay, so you know what? Let's. I'd like to show a screen here, and I'm going to do something since we can, and I'm going to show you how I can build something really quick. And bear with me here because I'm going to share my screen. Okay. So can everybody, oops, hopefully everybody can see what I'm seeing. And then I'm going to hit the build command. And then I'm going to show you how I'm going to do a simple project using the web. Now, I'm not sure why this is not quite responding. Oh, sorry, I know why. Okay, here we go. All right, so can everybody see this? I'm assuming yes. Okay, so so this is the Web IDE, and I'm going to simplify things. I have a bunch of apps.
Can you pump up the size a little bit?
Oh yeah, pump it up. Like zoom in a bit.
Yeah, please.
Okay, how's that?
A little bit more.
Okay. How's that?
Okay.
Is that good?
Yeah.
Okay, so you'll notice on the side here, I've got a bunch of apps that I wrote to test some things, and you know, I don't really have to, you know, there's my classic throwaway app, but what's really cool here is that out of the box, I can grab either a library or one of their samples. Now let me just quickly go over the libraries, and I'm going to show you some of the libraries that are starting to appear that people, so there's a NeoPixel library, there is a web server library, you know, there's you know, these are display drivers. Time alarms allows you to use the real-time clock and set alarms, which is really a fantastic library. We've got sensor libraries. We've even got a library for interacting with data gathering sites like Tembu, for example. And so there's even one for tiny GPS, and the list goes on. And what's really cool here is I can take a look at that library, and then I could actually use one of the sample applications, and there are many that you know, I could test. But I'm not going to do that right now. What I'm going to do is just run the simple Blink. So let's take a look at the really simple Blink code that everybody is so familiar with. So, you know, I mean, if you remember that the pin D7 is where there's a built-in LED, and in this application you can have a second LED on digital pin 0. And you know, this is a very complex application. Like an Arduino, we have a setup. So I set the two pins to output, and then I have a loop function that essentially goes on forever. And now I'm going to write a high, pause for 1,000 milliseconds, then low. So what I should be seeing is the LEDs blink. Now, since I only have the one LED, it's going to blink. Only that D7 one, that little blue one, is going to blink on and off. So how do I actually compile that and send it to my core? Well, first I'm going to select which Spark core I want. Now you notice I've got several, and there's the hamster one that I created for this specific demo. Now I'm going to say, do it for this guy, and now I'm going to go up here, and I'm going to do a simple. Sorry, this little thing. No. Sorry, guys. I've got something blocking. Aha! Here we go. So now I'm going to select this guy, and then go back over here and blink my LED, and I'm going to flash that to that specific core. Now, bear with me because I'm going to show you my camera. I'm going to send my camera, stop sharing, and I'm going to show you what happens when I hit this flash button. And okay, so again, I'm going to go down here. Can everybody see the core?
Yeah.
Hopefully you can. And I'm going to zoom in. And when I hit that flash button, it's going to send that. So you notice now the core is blinking. blinking magenta. Well, you can't really see magenta. But it's actually receiving the new firmware over the air. Okay?
So,
So
Paul, the script is identical to the Arduino Blink script, except for the designation of the pins.
you got it.
So the
It
main
is-
difference is instead of compiling and uploading, you're going to flash it. Is that right?
Absolutely. And Howard, that is one of the options, is to do it via Wi-Fi, or if I wanted to, I could do it via USB, just like an Arduino if you're really nostalgic. And you'll notice now, it is flat. You'll notice that D7, or that one LED that I have connected, is blinking. So, you know, there's two things that are cool about this. The first one is, obviously, I don't have to have it connected. But if I wanted to update the firmware of an application on a core that was not near me, I can do that over the air. So, so that's a really powerful function that is not common in a lot of processors. Okay. So, anybody have any questions on that part? Oh man, tough audience. All right. So essentially, Howard, what you pointed out was it's anybody that's familiar with Arduino will be very familiar with the Spark, except for the the pin designations. And on the Spark, they're logical: D0, D1, D2. And when it's not like Arduino that has a pin number and a pin name. In the Spark, they're the same. So it just means it's simpler to use.
So to make something self-contained with an Arduino, I would get something like a Teensy Arduino, and I would program it through USB, and then I would connect my output device and a power source, a battery,
right?
And there I go. What about Spark I/O?
Same thing. So I can power it. Whoops, let me just remove my camera.
Do I need something like a Teensy Arduino, or do I use the Spark Core?
No. So the Spark Core is a processor. It's the Teensy Arduino. The Teensy is essentially a Cortex. It's also an ARM processor. Well, it's the same thing with the Spark Core. We have a 72 megahertz processor plus the wireless, the CC3000 wireless module all in one. So it's a Teensy 3000 with a wireless module all in one single piece.
Oh, great. And
makes sense.
Again, show us how big that is.
So, okay, so let me just
thumb, for example.
So here is my here's my, I'm just trying to find a reference here. Okay, well, here's my thumb, and here's the Spark.
Oh, okay, so pretty small.
It's very small.
On Arduino.
And in fact, if you know the Teensy 3 or 3.1, it's about the same size. So, it's very small. It's very easy to integrate. And you can also get it with the built-in antenna, or with the type that has the wired antenna, the NFL UFL type of connector. So you can add a more capable antenna for longer range. So when you order it, you order the one you wish. You're the one you want. So here for example, I've got a project with a humidity temperature sensor, a Spark Core, and an SD card, and that all fits there, and it'd be very easy to integrate that into a tiny little board. On this project here, I've got a Spark Core controlling an Adafruit 16 by 32 display LED panel, RGB LED matrix, and I can send text and other commands via the web and by the way, there's a UFL antenna, not a very good one, and display it on this RGB matrix. And it's that, you know, there's not a lot of hardware here. There's a lot of wires and a connector, and that's it, because everything is built in. And I'm going to take a minute here to show you kind of a really cool project we did. Teek, do you have that app for sending text to the torch?
Yes, I do.
Okay, so I'm going to shift over here my camera to this little device here, which I'm going to turn on here because I've actually turned it off temporarily, so we wouldn't be distracted. At the show, this thing was insanely popular, and you'll see in a second why. So this is called, and I'm just going to bear with me here. This is called the Message Torch. And I'm just going to try to bring it a little closer here, and hopefully everyone can see that. There it is. Okay. So what's really cool is it looks like flames coming out of this torch. I'm just going to bring it a little closer even. And what it is a single Arduino Spark core, no other hardware except this strip, this 4-meter strip of NeoPixels, which are smart pixels, and everything is done by the Spark core. So calculating these flames, doing all of that is all done by the Spark core. Now, because you can access this through the Cloud OS directly, Teek is going to send a text that will display on here and scroll by like a marquee. And hopefully you can read it. It's really bright, unfortunately, and I have to apologize. And maybe you can read it.
I can half make it out, but only because I know what it's saying.
I know. And what it says, and it's so bright, what it says is Geek Out's rule. And so I have, you could send, I don't have the little application running, but you could send a tweet to it. Or you can send any text to it. Or it could display the temperature and the humidity if you wanted to. And what's really cool on top of that, if I can just put this down for a second, and I'm going to
have a link for that specific project.
I do, and I would be glad to show that to you in a second, and that's on our community.
Is that an LED belt or a NeoPixel belt?
Yeah, it's called a NeoPixel string, and that one, Howard, is 4 meters long. And we've got lots of folks building it, and it was built from one of our members who did an amazing contribution. And let me just send you that link. Send you that link right now. And I need to point you out that it's all open source. So this is shareware. So take a look. I'm sure it could be run on an Arduino, but of course without necessarily the fancy cloud connection that the Spark does. But here's a cool thing. So if anybody knows Pebble, this is a Pebble watch. We sat with Pebble and had fun creating things, and so we actually wrote a really simple Pebble app that allows me to, and I'm just going to load up that app right now as soon as I can hit the button, and it allows me to do some stuff with this lamp. Now, there's, you can't really see it, but there's the app, and I can hit 2 buttons on my watch, and I'll show you what they do. Okay, so there's the lamp, and I'm just going to turn off this light here, and now I'm going to hit the first button and change the mode of the Spark, and now it's gone into a rainbow mode. Okay, so the text keeps going, but it's in rainbow mode. Okay, go ahead, post that. So there, Teek just went rainbows and sent that message over. And now we're going to go back to to the funky fire, and I can switch modes really easily. Now, here's a cool thing that we also added. Because this watch has an accelerometer, I have what's called the Harry Potter mode, where I can shake the watch and it'll flare up, like you just saw there. It'll flare up the flames on the message torch, and we did that in one afternoon with very few lines of code. Just to show you the kind of integration that you can have with Spark Core and other things like SmartThings and Pebble to begin with. Okay, so that's what got me really excited, because you don't have to do a lot of the legwork that you would normally have to do with other devices. The Core has that out of the box. So, anybody have any questions? And we had a couple of new people also, Madan, and I think that's it. And any questions regarding, the library stuff? Anything I can clarify? Because we've got 5 minutes to go, Q&A time.
This has been fantastic. How hard is it to build that torch?
You know what, Howard? That's a good question. It is so ridiculously simple. I mean, the two things you need that are tricky is a good power supply that has enough amps. It's a 5-volt power supply that can light the lights, and in my case, it's 5 volts, 2 amps. And then you need the string of NeoPixels that you can buy. And the trickiest part of all the things is the diameter of this of the tube that you wind it around. Because what you're looking for, Howard, and I'm just going to grab my camera here, and hopefully you can see. You'll notice that the LEDs, when you wrap them around, they kind of have to line up vertically.
Yeah.
For the effect. So the toughest part of this is finding the right diameter tube to wrap them around. The original author...
A source for that?
I don't, but there are so many people who do, and I can even share the diameter of this one. And we've got a gentleman who is going to attempt to do a 12-meter version of this. So you can imagine the tube is going to be much longer.
I'd love to make one of those. Are you interested in doing a build-along?
I would love to.
Okay, great.
And certainly we can share, we'd love to share what we know. And I can share the diameter of this acrylic tube. I'll be honest with you, I was lucky. But because originally they were supposed to go inside, and the inside diameter is just enough off that it didn't make it look right.
Well, I think you just look up acrylic tubes, and I bet you could find exactly what you want.
Absolutely.
Oh,
Absolutely.
This is great. I think this is not going to be inexpensive. It's probably about $50 just for the LEDs, or
yeah. You can find those LED strips. You can find about 5 meters in say AliExpress for about $50-$60. And those are the weatherized ones because they're a little gummier and they stick better. And then the Spark Core, of course, is $39. And the power supply, I purchased one because I wanted to make sure I had enough current. But it wasn't very expensive. It was like $12, $15, I think. And that was...
So you're talking about $110.
Yeah. But
Fantastic.
What an attention getter this is, I'll tell you that. It's a lot of fun to use.
Fantastic. Do you think that you could actually build it within an hour?
Boy, that's a good question. Because I built mine on a little board, yeah, you could put it on. You could easily put it onto a proto board like this one, and do your wiring as long as you had all your parts ahead of time. Yeah, it could be done in an hour. And Howard, like I said, the toughest part is having the right diameter tube and the LEDs. but you know what? We could probably string it together in an hour.
Yeah. Okay.
Any comments on that?
I think you could do it in 47 minutes. I've seen you hustle.
All right. Before we close, any other questions? I really want to answer any other questions people might have. Oh,
We lost Caleb.
This has been great. Thanks so much. I really look forward to doing a build along, and I'm willing to invest the money if I could get that thing working.
well, you know
That's
what?
very impressive.
Howard, I can tell you, I really appreciate the time you've given us. You know, certainly me, and the ability to share our excitement with this product. And I hope that anybody who has any questions will find our forum, because our forum is very active and very. We love to answer questions, especially with people who are trying to discover the product.
Great. Thanks so much.
What's the website again, so we can share it for everybody?
Spark.io, and there's a community button there, and you can find everything there. My handle there is PK123. So if you see some guy sounding, like he has no idea what he's talking about, that's me. Caleb, any questions?
Oh, yeah, I just came back. How easy is it to connect to an SPI device? Do they have like proper library, or is it still like a community library?
Yeah, SPI is built in, and we're actually now working on adding SPI DMA, and we have a lot of experience with SPI, and any questions you have, the community would be super happy to answer them.
Okay. And I heard that you said you got some device connected with SmartThings. How easy is it to do that?
Well, all you need is a SmartThing hub, because otherwise you can't register as a developer.
Yeah, sure.
And then the rest is it takes about half hour. Everything's on one of the topics on the community.
Okay.
Cool, huh?
Yeah. I'll try that out soon.
Excellent.
All right, so
All right, guys.
yeah, let's go ahead and wrap it up. Thank you so much for everything. It was such a fantastic presentation. It's spark.io for everybody watching out there, and please join us on Pursuitery.com. We have a variety of other geek outs coming up. Hopefully, more about all kinds of dazzling electronic torches, as it were. That was a highlight of my evening, and I want to go ahead and wrap things up there. Again, Paul, Teek, everybody else who joined, thank you so very much. Have a great night, and take care. See you soon.
Thank you.
Guys.
Thanks a lot, Paul. Thanks, everybody.